Hi everyone, this will be a crash course for microcontrollers and how they work. So this is basically what you're gonna learn. You're gonna learn some embedding theories, some theory about how the different peripherals, and some programming techniques. But I think you might already know these things. So the big goal of this course is actually how to make use of HAL APIs to speed up your development, how to use HAL APIs to become a better programmer and to program those microcontrollers faster and easier. So I'll show you the workflow, the software you'll need to install, and the code structure. So I'll guide you step by step to all of these things. So of course there are some things you're gonna need. So the first thing, of course, some basic programming skills, some basic knowledge of embedded devices, what a clock is, what peripheral is, and of course you also need an STM board. Otherwise, you cannot see those concepts in practice. You cannot test the code, and of course, you'll not learn so much. Of course, I don't expect you to have an in-depth knowledge of microcontrollers. This is what we are gonna learn. Of course, in the end of the videos, you're gonna have better knowledge and grasp of all of these concepts. So why I'm gonna focus on HAL APIs because of course they are easy to use. They will simplify your job and they're accurate. That means that I don't want to say they are flawless, but most of the time it will be your fault if they don't work because they're almost 100% accurate. And of course, as I said, it will simplify your job because you are not gonna write any macros, function, initialization, definitions. All the APIs will do the job for you. So this is actually what an API is. They will simplify your job. They will create some functions, initialization. On the other hand, there is register level programming, and of course you'll have some more freedom if you configure every register manually. You will have more freedom. You will be able to configure more, but of course you're gonna make a lot of mistakes that are hard to debug, and of course it will be so slow, will take so many hours to just toggle analysis. So just crazy. And so I'm not saying that register level program is worse than HAL APIs. I mean that most of the time you're gonna just use HAL APIs and do everything quicker, and we will gonna focus on how they work and how to use them. So this is the workflow we're gonna take. First thing we're gonna do is to create the project with STM CubeMX software. We'll program our logic, program all the code from scratch. We're not gonna use the code produced by STM CubeMX software, and we will of course compile the code, run the code, debug the code if necessary, and so on. So the first step is to download STM CubeMX software. So I already have it here, so just type STM CubeMX software here, just click on the first result and click here. I think yes, of course, I didn't see this button appear. Just click on get software, click on get software again, accept. It will ask you for first name, last name, and email address, so it will send you the link to download the software if you just complete these fields. I'm not gonna do that because I already have STM CubeMX software installed. It is actually already running. Let me run it again. Okay, so it will start STM CubeMX software, STM CubeMX software. Then you're gonna download some IDE. I'm gonna use Eclipse, but you might use other IDEs. I don't know. You might use STM32 Cube IDE. It's pretty cool. Or HAL is also a popular choice just for Windows in this case. So just choose and download the IDE of your choice. I'm gonna use, as I said, Eclipse, and this is here. I need to open it. Just STM. This is Eclipse. And so the third step is actually to open CubeMX software and select the target board. So here we are. So we'll click on File, New Project. Wait some second, it's doing stuff, and then we will click on Board Selector, and STM. In my case, I have a nuclear board, so if you have a discovery board, just click STM, I don't know, F0 or F4, and you'll have the discovery board here. If you have a nuclear board like me, just type nucleo. In my case, I have 446RE. That's here. Double click on the photo. Yes, and it is basically now configuring the project, creating the project for me. Here we are. We have these. I don't know if you are familiar with the STM Kubernetes software interface. Here we basically have the possibility to configure everything from this interface tool. So from this graphic tool, we have the possibility to configure the timers, the clock. Here we have the clock table. We can change the clock configuration, and of course, every change made here will be done after we generate the code. And of course, we have the project manager. Here we just need to type the name of the project. I will name GPIO 1. I don't know, just give it a name. Let me write them in capital letters. And we need to select the tool ID we will use. In my case, I will be STM Kub. I will be SW for STM32. This is basically Eclipse, another word in our terms. Just copy in only the necessary files, and here we are. We don't actually need to add everything because all the necessary need for toggling the LED is already done here. We can just now click on generate the code. Wait some seconds, it's generating all the code necessary for our project here, and click on open project. I always prefer to click on open folder. Let's copy the path of our folder. Let's go to Eclipse here, and in this case I had already done some settings, but I don't want to do it from scratch. So let's click on open project. Let's click OK. Okay, here we are. Here we have the project. So now we just need to do some other settings, like removing all of these files. So let's get back to our diagram. So we configured and added the code to the project. We generated the code and opened the project in the IDE. Let's go to step 6. Step 6 is open the project in the IDE. We already did it. Remove some of the generator files. So I'll show you what are the files you need to remove. These are the files: the main.c, msp.c, it.c. So I'm actually removing all these files because, wait a second, so you can just open these files. So it has already done everything for you, but you don't want this. So you want to know how to use these APIs, because actually STM Kubernetes software actually use the HAL APIs to do this configuration, but we want to learn to do it ourselves for jobs as developers. And here we will remove everything from the inc folder, and then we just can create the other files. So main.c again, we need main.c. We also need file, we need it.c, we need also msp.c. So in these files I will explain you what it will do. So main.c is the main file. Well, it expects to have an int function, of course, and otherwise will throw an error. And in it.c we'll put everything related to our interrupts, and we'll also need to create some files in some other files in inc folder. So I'm at main.h, of course, where all of our macros and the functions declarations will go, and also it.h. It is needed, actually not needed, but I think so. This is actually what we created, add all of these things, and then we are ready to start coding. So everything we did until now was not a waste of time, of course. This is just a template we will use every time we're gonna program some code. We're gonna do some exercise. We'll always have the same folder structure, file structure. So in the next lesson we'll start coding, so I'm so excited to teach you how to use them, and I'll see you in the next lesson.